child or every, what to say, root has a two child only, two child policy only, right? So हम दो हमारे दो, same way every root or every node has only maximum two child, so 0 1 or 2, right? They can have that much only. And there are four kind of traversal: in order, pre-order, post-order. It is a typing mistake over here. So in order is left root right, pre-order is root left right, and post-order is left right root. So that's how we traverse the tree. Now I'll explain you the whole program, how to make this program in a better way. So initially we need to create a class of node. Whenever we are creating a basic binary tree, so there will be three data. One is int data, that for storing the data. Second is node left for left reference, node right for right child reference, and the constructor where we will take the data, and total node this dot data is equal to data, and left is equal to null, right is equal to null. So that's how we create first node or one node at a time. Now let's create a binary, one more class, binary tree test. So we will going to create our binary tree over here. Now in creating a binary tree, we will create in this program four functions: one to create or insert a node, uh, and three functions for different traversal: pre-order, in order, and post-order traversal. Okay, how we are going to traverse the tree. Now uh, initially let's create node insert. And because we are thinking to take data from the user, to do the import also, import dot util dot scanner class. In this insert, first create an object of scanner. Sc is equal to new scanner system dot in. Now after creating this, we need data part also, and data is there, done. And then create one more thing, that is node temp, because our return type is node over here. Now if whatever data user enters, now I'll tell the user also to enter the data, enter data, and user will like enter the data. Data is equal to sc dot next int. So when user enter the data, data will be stored over there. But if you understand the property of a tree, so tree is a recursive functionality. So when we are using recursion functions, so there should be a point where we should stop the recursion also, na? So in that scenario, what we do, we are saying ki, okay, if data, if user enter data as a -1, right, then we should end it, end the recursion, return null only. Else what we can do, we can in else what we will do, first we will create our temp is equal to new node, and transfer the data into that constructor only. Now we need to call recursion for the left subtree and right subtree. So what we will do, we will tell user to enter, and we are entering this as a pre-order insertion only. Enter data for left of the data, print data over here, and let's say done. Right, now call the same function recursion. We will start the recursion same function for the left part. Temp dot left is equal to insert, right? Then we will do the same thing for the right also. So over here, enter the data for the right of same data, and temp dot right. So when you call the recursion for the left and right both, Now return temp only. So this temp will be returned as a root node at our insertion point. So let's, it is closed. So this else is closed, then this function is closed. Now we will create those traversal functions. So void traversal for pre-order node root. So we will transfer that root as a parameter over here. Now first condition in every traversal, we will check only कि if root, till the time root is not null, we will go on, right? And because it is pre-traversal, so what we will say, okay, let's remove it, system out dot print the data of the root. In pre-order traversal, we will traverse as a pre-order means this order is decided on the basis of root. So root left right is pre-order. So we will print the root data, and then after that we will start the recursion. So recursion for the same pre-order, root dot left, and then pre-order root dot right, and we are done. So that's how we traverse. So void pre-order, then let's create one more function, two more function basically. So void in order same root is transferred over there. When root is there, so if till the time root is not is equal to null, we will traverse this data. And in order is means root will come in between left and right. So left, root, right. So in that scenario, what we will do, we will call first recursion, left recursion first. So root dot left, and system, we will use the same system out dot print over here because root will be printed in between. Then in order will be called for the root dot right. Same function recursion will happen. The third recursive function is in post order, and we will pass the same root node over here. And in post order, what we will do, left, right, root. So if root till the time is not equal to null, what we will do, first we will call post order for root dot left, and post order root dot right, and then we will use to print this data, system out dot print root dot data, and we are done. So now we have created 4 functionalities over here. Now we will create our public static void main. So over here, let's create the object of binary tree example or binary tree test. What class we have created over here? Binary tree test. Let's create the basic object of is t is equal to new. Now first we will call the insert function for the tree. Now the t function, the insert function we have created as a, where return type of insert is node. So this temporary node will be returned as a root node after completion of insert. So we should hold it into this root. Node root is equal to t dot insert. Now we are going to call three traversal t dot pre-order, t dot in order, and t dot post order, and it is parameterized function है ना, so we will pass root in all the functions. And because over in function we are using system out dot print only, so because it will not create hodgepodge, so we will be entering this println, and let's save it. I think it is done. So let's save it as a binary
Sir,
tree
curly
test.
braces
Which curly braces?
at last term.
It
There
is,
were should be two.
yeah, it is there. Don't worry, I'll show you. Binary tree test. The curly braces are there, but it is so, you know, below the space that you are not able to see. This is the curly space. Basically, in coding, I normally code on maximum code. If you are saying I'll code on Notepad, so whenever I'll create one open curly braces, I try to close also same time. Otherwise, it will create hodgepodge. In maybe VS Code or maybe what to say, NetBeans and Eclipse or IntelliJ, you will find it very easy to operate. But yeah, in Notepad, you have to call it in the right way. Otherwise, it is not forgiving you. The same. Again, there will be error because again some semicolon, some spelling mistakes. But it's good to solve errors, I think. Uh, okay, so it is compiled without error. So binary tree test. So enter data. Let's create one more thing over here. The same time we will, over here we will be creating the tree also. So first number will be our root. So let's give me number for the root.
17.
17. 70. Enter. Up now it will asking me enter data for the left of 70. So let's say कि 70 is our root node. ठीक है, now first we will traversing into left mode. So pre-order insertion is happening, means root left right. So enter data. So we will be entering like, okay, we will enter 50. So 50 will be the left of 70. Then enter the more left of 50. So like we will say कि okay, 40 will be on the left. So 40 will be on the left. Now I'll say कि okay, enter the data of uh, more left of 40. So I'll say कि no, I don't want any child for 40. So I'll say कि okay, minus 1. Left of 40 is minus 1, means null is stored. Enter data for the right of 40. Minus 1, I don't need child over there also. Now it will, after entering, saying no to 40 left and 40 right. After that it will store for 50 right. So whenever we enter, now enter data for right of 50. So in right of 50, I'll said कि okay, let's store 55 over there. So 55 is in the right of 50. Now if I'll say कि okay, I don't need child for the 55, minus 1 and minus 1. For left is minus 1 and right is minus 1. Enter data for right of 70. So 70 is the main root, where now we are entering in the right side. So we'll say कि okay, let's enter 200. So 200 will be entered over here. So now it will again asking the data for the left of 200. So left of 200 will be, let's say, 80. 80 is there now. Uh, right, and let's say I don't want child for the 80. Now enter the right of 200. Now I'll say कि okay, enter 800. So 800 is entered. Now it is asking for left of 800. I said कि okay, 400. Now I'll say कि okay, now 800 is here and 800 left is 400 over here. I said कि okay, now I am done. So I don't want child for 400, any child. Now I don't want any right child for 800, minus 1, and we are done. Now We have printed pre-order, in-order and post-order traversal over here. Let's calculate ourselves कि okay, is it right or wrong, how it's working. So let's look at first again. I'll pre-order, in-order, post-order, right? And what was the logic behind pre-order? Can someone tell me? Root,
First, we will print the root node and the left again right.
right. So root left right. In order is left, root, right, and post order is left, right, root. So this traversal is again only root is changing. Pre means root is prior to everyone. In order means root is in between left and right, and post order means root is in the end after left and right. So in pre-order, if we will look at it, root left right. So first we'll print 70, then left side there is 50. Now 50 itself is a root of left subtree 50, then 40, then 55. Then if we'll come over here, there is 200, then root left, then right 800 and 400. So this is our pre-order. If we look at it, is it right or wrong? So 70, so 70, 50, 40, 55, 200, 80, 800, 400. So we are right. Uh, Now can somebody tell me in order what will be the sequence for in order?
First, we will print 40,
So let's we print 40,
again 50,
50,
55,
55,
70,
70,
80,
80,
200,
200,
400,
400,
800.
800. So let's check it out. So 40, 50, 55, 70, 80, 200, 400, 800. Someone else want to try post order sequence? Uh, Prashant, Jayashree, Raja, wanna try this post order? क्योंकि
Sir,
what will be the post order for this?
55, sorry, 40,
40,
55,
55,
50,
50,
70,
70. No, no, no. 70
80.
will not come. Not come.
Okay, that
70
is
is the
root,
top
no?
node root. Left, right, root. So left, right, root. Left subtree is complete. Then right subtree will be completed. After right subtree, 70 will come. 70 will be the last node
400,
into post order.
400, sir.
No. 80.
So when the recursive call will be occur, we will firstly we go to the paste left node, na?
Yeah. So initially you was right 40, 55, 50. The left subtree is completed. When you go to the right, the left will be 80.
Sir, we will go first full the paste node, na?
Deepest left node.
Okay,
I'll tell you okay how. Left right root. So in this subtree, this is left, deepest left right.
okay,
After that, we will go to this right. Then 50. When we will come to the right, so first left deepest is 80. Now in this subtree, right is this. When we'll go to the right, then we will print this 400. 80, I think 400, then 800, left right root, then 200, then 70. This is what I think. Let's check it with the system only. So 40, 55, 50, 80, 400, 800, 270, right?
yes, sir.
So just don't get confused ki deepest or anything else, just focus on that only, left right route. So when we started, we went to the left, uh, we have printed the left, now we will go to the right. So 55 is the right. After completing 40 and 50 left and right of this root node, we will print this root node. So left, right, root, right? Then we will go to the right subtree. In right subtree, 200, then 200 has a left and right. So let's print 80 first. Then we will go to the right side of over here. Over here already there is a left. So we will go to the left of this 400. Then 400 don't have any right brother. So we will print their root. Right. Now 280 left subtree is completed, right subtree is completed. Now we will print 200. Right. And after that, this left subtree is completed, this right subtree is completed. Then we will print the total root, the 70. Is it clear, everyone? How we created this program, or is there any confusion, anyone? You can ask me questions. matlab, It will be great for us also. Prashant, Jayashree,
Yes, nothing.
is it clear or is there any questions?
Yes, it's clear.
Okay, great. Yeah. Uh, so I'll share this program in our group also, right? So okay, in order also. Okay, I'll explain. Let's go. So let's first I try to create that over here also. So let's say this is 70, right? And in 70 is left, what we did 50, and on 50 left we created 40 and 55 to this right. Then we will go over here like 200, then 80, then 800, then 400, right? So again, matlab, it is matlab, don't read this one is little bit wrong. So what is in order? In order means left, root, and then right. Okay. So first we will go to the left, then root and right. Now if we will start this, uh, this is the basic main root over here. So first we will go to the left, we will go to the left subtree. Now it is root. For this root we will go to the more left, so they have the left. So first we will say 40 left, then root. So root of 40 is 50, then right, the right of this root is 55. Then the left part is completed, right, this part is completed. Now we will go to their root, because left is completed, their root is 70. Then we will go to the right subtree, right. Now this become the new root for this subtree. So first we will go to their left, so 80 is their left. Now 80 is completed, this left subtree is completed over here. So 200 become the root, so we will print 200. Then it will go to the right, so now it will go to the this subtree, right. So when this becomes a root, we will print their left is 400. So when 400 is completed, there is only one root left, that is 800, means 800 will come. So again, if we look at the in order, I hope we have done the right thing. So 40, 50, 55, 70, 80, 200, 400, 800, right. So our this traversal is very simple. What we did over here, we said ki okay, we in order traversal we will go left, root, right. So what is the left? This is the This is the root over here. This is the left subtree. In this left subtree, it is the root. So in it is the root, then it is the left, then it is the root, and it is the right. So left, root, right, right. Then this subtree is completed. So this is the root for them. The 70 is the root for them. Now we will go to the right. When we will go to the right, this become the root. Then this become the left part of that root. So left, root, then right part. But when we'll go to the right part, this become the root. The left of root is 400. So 400 will come first, then left, then root, then there is a no right, and it is completed. So is it clear? Can someone confirm? Okay.
Yes,
Okay.
sir.
So I'll share the program. So Saturday, Sunday will be off. So we will on Monday we will be continuing the binary search tree. So binary